we have all these compounds, and they all have names, and they all have formulas. So a chemical formula is the shortest way to specify a compound. The formula indicates which elements are present in the compound and how many atoms of each. How many atoms or how many ions. And we use subscripts to tell us how many of those are present, and we use the element symbols to indicate which elements are present. So water is H2O. The 2 after the H means there are 2 hydrogen atoms and 1 oxygen atom in this molecule. Sodium chloride, NaCl, 1 sodium ion for every 1 chloride ion. Carbon tetrachloride, CCl4. So there's 1 carbon atom and 4 chlorine atoms. Now, chlorine, you have to be a little careful with this one because that kind of looks like a capital I, right? Or a 1. It's actually a lowercase l. Can be hard to tell. So sometimes people will think this is carbon, and 4 iodines. But if we had 2 carbons, it would be C2I4. Any questions yet? We can categorize chemical formulas into different types. The empirical formula tells us the relative numbers of atoms of each element. So the empirical formula for hydrogen peroxide would be HO. That's the empirical formula. The molecular formula is H2O, 2. Save that one. Each molecule has 2 hydrogens and 2 oxygens. The empirical formula is just going to give us the lowest ratio of atoms. And that's because empirical means from experiment. So when you do an experiment to find what's in a compound and determine its formula, the first formula you can determine is just the empirical formula, just the ratio. Molecular formula tells us the actual number. The actual number of atoms. So this is what we typically think of as a regular formula. And here it's giving us some examples of looking at the empirical versus the molecular. So for this compound C4H8, if we want to find the empirical formula, we're looking for the greatest common factor. How can we simplify 4 to 8? Well, that would become 1 to 2, right? Simplifying a ratio or simplifying a fraction. Structural formulas use lines to show covalent bonds and actually show how the individual atoms are connected to each other. There's a single line for single bonds, a double line for double bonds, a triple line for triple bonds. And we'll talk about what those are later. Which formula we use depends on how much we know about the compound and how much we need to communicate about the compound. Structural formulas have the most information, empirical has the least information. Write the empirical formula for the compounds represented by each molecular formula. So C5H12. Can a ratio of 5 to 12 be simplified? No. So the empirical formula here is the same as the molecular formula, and that can definitely happen. How about Hg2Cl2? We'll divide both of the subscripts by 2, right? And we get HgCl. That describes the ratio. How about C2H4O2? CH2O. So we're just looking for the greatest common factor. We factor that out, and we're left with the lowest ratio. We can also use models to represent compounds. Good to have some. These are examples of ball and stick models. So cleverly named because they use balls and sticks, right? You know, we're not trying to be tricky when we call these things, give these things names. Typically, the elements use the same colors. So, you know, when I look at this, I know that the black ones are carbon, the white ones are oxygen, and the green ones are fluorine. What did I said oxygen, didn't I? Yeah, shows how much I know. Those are hydrogen. I thought hydrogen. You don't need to memorize those, but you should just be aware there is a color-coded system for those. A space-filling model shows us more like what a molecule would actually look like if we could see it. So this is the space-filling model. Because molecules are not atoms with skinny bonds in between. This is easier to make, it's easier to look at, especially as a two-dimensional picture. But this is more like what that molecule would actually look like. So space-filling model, ball and stick model. This is the structural formula showing that the hydrogens are connected to the carbon by single bonds. And this is all the molecular formula of CH4. This table shows the different formulas and models for several compounds. Let's just look at glucose, sugar. Empirical formula is CH2O. There are a lot of compounds with that same empirical formula. Its molecular formula is C6H12O6. And here in the structural formula, if you count all the O's and H's and C's, you'll find out that this is correct. There are actually also a number of compounds that have the same molecular formula, but they are just connected in different ways. Those are other sugars, like fructose. Here's the ball and stick model and the space-filling model. This gives us the shape of the molecule, but if we're looking at that picture, we can't see the other side. So it's most useful if you actually have a physical model that you can turn around. Here, we get a vague idea of the shape, but we can also see what's on the other side.